everyone, and welcome to today's session hosted by SAR Education. My name is Diksha, and I'll be your moderator for this event. We are excited to have you all here to learn the usage of maths manipulatives in primary section. Today, we have Ms. Zaira, who will be sharing her knowledge and experience with us during this session. So before starting the session, I would like to share a few guidelines with you all. So we'll put everyone on mute except sorry.
You're on mute.
So sorry. I'm so sorry.
It's okay.
So before starting the session, I would like to share a few guidelines with you all. We'll put everyone on mute except for our speaker to avoid any disruptions. We also want to make sure that you have an interactive and engaging session. So please don't hesitate to participate and ask questions. Over to you, Ms. Zaira.
Thank you, Diksha. Before I start my session, I would like to share my screen. Just give me 2 seconds. Okay. So yesterday we had a session on foundational stage where we learned how to use manipulatives, right, to learn mathematics, not to do mathematics, right? So actually what happened that for many decades, educators have been taught to teach mathematics by repetition and memorization, right? They have learned to see mathematics as a set of rules and procedures, and so that's how they have taught it, right? But truth is that students can't build a strong foundations or understanding for mathematical concepts when they are taught to memorize the rules and steps and procedures, right? So what exactly we need to do in this moment then? See, because as an educator, I also used to follow the same method to teach the students. Even the way we have learned mathematics in our own classroom, we try to implement the same thing, same procedures, same steps in our classrooms to teach students, right? So what exactly we need not to teach the students? Our students do not need to be told what to do while solving any problem. They need to learn how to think about that situation or problem, right? That is the main like crux of the understanding, that what exactly we need to identify in the classroom or need to implement in our classrooms, right? So let me just recapitulate the things that we learned yesterday, that fluent in mathematics or anything in our life, it is nothing but being fast, being accurate, and have the flexible thinking into me, right? But what exactly do I need to do in my classroom or in my surrounding to develop a mathematical understanding or mathematicians among these budding learners? So what exactly the formula is to make our learners flexibly, develop the flexibility thinking among them, right? So what exactly, see, first of all, as an elder, as an educator, we have to understand what exactly we are lacking in our understanding. The way we have been taught or we have learned the numbers, we should understand that is not the accurate or correct way to look at a number, right? Understand the number. So first of all, I have to understand myself. I have to build my maths mind, and then I can transfer that knowledge to my students, right? And then I have to observe like what exactly I did and what exactly my children need to understand that concept. We have learned to follow a method, follow a rule. But if I'm observing that my children are not learning, not understanding, that they are struggling, so what change need to be done in the classroom? Then I have to connect the changes connect my students with those concepts that we want them to learn in that. And then we have to provide the experiences in the classroom. They have to have a opportunity to experience those abstract concepts and knowledge in their own learning, right? So before I go further today's session, I start to open the like manipulative side to understand the different activity and concepts. I have a few questions for you. So can you just tell me, in your own understanding, what do you understand by the word struggle? The first three words that come into your mind when you hear the word struggle. Quickly, just send your responses in the chat box. Yes. Difficulty. Okay. Inventions. Yes. Stress. Okay. Creativity. Okay. Yes. Thinking out of box. Struggle means thinking out of box, not able to understand. Okay. Yes. Not able to solve problems, confusion, difficulty, effort, understanding. Yes. Facing problems, hardship, innovation. Yes. Confusion, how to teach, try to understand. Yes. So if I just try to like go through your all responses, and I can see that most of the reply is for difficulty, right? Struggle means difficulty, and which is not good at any sphere of life. If you are facing any difficulty, it means it's not good, right? It's bad for your progress, or you can say that it's bad for your understanding. But if you ask me, I want to argue on this, because as per me, struggle is nothing but is a part of your learning. It's a necessary part of your learning. If you are struggling, it means you are trying to learn something. Your brain is working to learn something, to solve some puzzle, solve some problems, right? So struggle is needed. So if I unpack this word in real context, so I have few things to share with you. See, while I'm learning this by riding bicycle, I'm struggling to learn this ride, right? But when I am struggling, it means I'm trying to get the idea, get the process, get the concept, how I'm going to learn this riding the bicycle, isn't it? So this struggle is fruitful for me, because it's teaching me that how to ride a bicycle. Similarly, if I just try to visualize this kind of struggle in my own classroom, if you can see this swimming instructor, what she's doing, she's just trying to guide that child how to learn swimming. She's not moving her hand, or kicking her legs to teach this child how to swim in the water. No, not at all. She's just there to observe and making and feeling that child, that be confident, have faith in you, you can do it, and I'm here to help you out, and you are not going to die. These are the things that she is there to tell them, right? And the struggle is really is for the child to learn that swimming, and through that struggle they learn how to swim. And when they develop the flexibility in their own understanding, then they can do a lot of tricks, a lot of different style of swimming by their own. They not need to learn all of those styles, right? And similarly, if I can visualize this scene in my classroom during my mathematics class, what we do, we just give them the whole step. These are the steps you need to follow and do the maths. What exactly we are doing? We are not behaving like a swimming instructor. We are just doing the part that the children need to do. We are doing that, right? So that's the change we need to include or implement in our classroom. We need to be like, behave like a facilitator. And for that, we need to develop that understanding first in ourselves, because we have never taught this kind of things in our school life, or we have never taught to teach like this, right? So we have to develop that understanding first, which is the first basic essential part of your building flexible or the flexibility among the learners, right? And same thing happens when you try to learn driving. So whatever things you learn in your real life, it's just not the related to your education, any part. It's just that you have to struggle to learn. You have to identify your comfort zone. You have to identify your the soft corner or the hardship that you need to identify, and you have to overcome that. Just as a teacher, you need to be there for help, right? Yes, it's true that there are moments when explicit instructions of skills or the concept must be provided. But before such instructions happens, students must have the first crack at making their own meaning. Let them explore, let them conclude, let them identify the pattern by themselves. Then if you feel that they need your help, then intervene, right? That's what is about the learning maths. It's just not doing maths to use with using that manipulative. What exactly the difference between these two phrases are? Can anyone tell me? I would also like to know that what do you understand by the word that I do maths using manipulative, or I learn maths using manipulative. Yeah, I use manipulative to learn mathematics. What is the difference that you understand through these two statements? Yes, I would like to hear from you all. What do you understand by the statement that I do maths using manipulative, or I use math to learn mathematics? I do maths using manipulative. This is one statement. And I use manipulatives to learn maths. What the difference you understand? Learning by doing and more interesting. Okay. Which statement you find is the most appropriate for my mathematics classroom? Which one? I do maths using manipulatives. Okay. Both. Okay. Okay. So I'll just share quickly two examples. Second one, learning by doing, I use manipulative. Yes. Suppose if I ask you to just let me know what is the sum of 50 and 12. I'm going to use this styles. Okay. So both the way, in both the statement, the manipulative is used, right? So now the first statement, I do maths using manipulative. Okay. So 50 and what was the number I told? I forgot. 50. Just let me write it down here. 50 plus 16. Okay. This is my number. I want to have the total out of it. What is the total of these numbers? So I'm doing maths, right? I'm doing maths using manipulative. So I know 50. I'll just drag 1, 2, 3, 4, and 5, right? 50. And then I know 50. Okay. I know this 16 has 10. So I will have 10, one more 10 over here, 60. And then I have 6. So I will put 6 over here, right? So this is my 6. So I'm doing maths. I'm just calculating this thing into my head by following a proper, or you can say a procedure that I have learned in my school time, or something I have learned or memorized the steps. That 50, I need to add first 50 with the tens, and then I have to add keep that 6 here. So I'm just using this manipulative to not verify exactly what I have learned as a process. I'm just putting manipulatives there. This is how I have done maths using manipulative. But if I'm learning maths I'm using manipulative to learn maths, the very next moment I need to understand what does it look like? How does this 50 and 16 become 63? Sorry, 66. How does it become? If I want to draw some structure for it, how is it going to look? Right? What is it? It is kind of problem. So if I'm making sense of this maths question, so I'm going to use my whole understanding and flexible thinking into it. So 66, it means I have 6 tens and 6 ones, and how I'm going to draw this as in a form of a structure. So I can make it out that I have 50 here. Yes. And I have to add 16 into it, and I have to find out. So I'm getting into the problem first. I'm understanding the problem first, then I'm trying to solve it. I'm just not jumping into directly into the solution, right? So this is my whole. I'm just making a connection between these two numbers and the symbol that I'm using here, and then I'm using my this manipulative what to do. So this is very simple examples. Maybe you are not able to understand what exactly I'm trying to mean. Let me take some more complicated problem so that it will be easier for me to explain, right? So I have, now I will change into 57 and 16. So as a rule that I have learned, so I will just do 57 and then count forward 16, because 16 is the smallest number between these two. So I will just count forward 16 and come up to the initial, final answer. But if I am using this manipulative to understand what would be the sum, what would be the total, so I'm just going to represent the numbers first. So 57 means I have to have 5 tens rod and 7 ones. Okay, so this is my 57. Yeah, and now I have another number which is 16. Okay, so I'll drag one more tens and I'll try to make a group of it. Yes, drop and copy. I'm having and this is my 6. So now I'm going to use my flexible thinking and the concept that I've learned. Then whenever I'm going to represent a number, I need to unitize. I need to use the process called unitization to make it as a whole number, represent as a whole number. So I can see, I can visualize that I can club this all tens together to make it 60, but I have to regroup these ones into tens, right? So again, I have to pull out, and I know that 7 and 3 all together can make 110, right? So if I just make a group of it, right, it becomes, I can replace this with 110, right? So how much or how many unit blocks I am left with? So I can see visually, and I have used the understanding and the connection between the ones block and a tens block to solve this problem. Here I have used my manipulative to learn maths, right? And this I can represent to prove my understanding and to give the reason behind my calculation. So I know this is my 57, right? And this 16 all together, it gives me a whole which is unknown, and I have solved it and found that it's nothing but 1, 2, 3, 4, 5, 6, 7, 73. So if I want my child to give a reason, like what strategy they used and what exactly happened in their mind to solve this question, so they must be able to give me the reason behind their thinking. Like they can give this strategy. See, I know this 7 needs more 3 to become 10. Okay, so I can split this 16 into 3 and 13. What I'm exactly doing, I'm just trying to break this number into two parts, which I have already learned in my previous lesson, that if I can break a number into two different parts, it's become number bond or the number fact, addition fact. So now I can combine this 57 and 3 as to make 60, and I'm left with 13, which makes me easier to add the number with tens, right? So easily I can add that 60 and 10, which makes 70, and this 3. So this is one of the strategy that I applied when I handle this concrete manipulative, right? So this is my learning maths using manipulative. I'm not just doing math. I'm not just solving maths, right? I'm doing faster, with accuracy, as well as with flexible thinking. This is my flexible thinking, which makes me able to solve any number using different strategy. And if you just take that, if you have gone through the NNCF, it also talks that the child should be able to be flexible in their thinking, and they should use more, several strategy to solve one single problem. Okay. Now, I'm just going to take, this was addition. Now, next, I'm going to take subtraction. So how I'm going to visualize or use this tool to subtract a 3-digit number or 2-digit number, because now I'm talking about grade 3rd onward students. So they have more than 3-digit number to operation for number operation, right? So I'm just taking 341 plus 19. Now check out. When it is easier number with 0, most of the numbers in benchmark numbers like 20, 30, 140, 300, 400, it's quite easier for the child to count it. But if you have an odd combination of numbers, they get confused what to do. And when they have to deal with the regrouping of numbers, values, and they get a lot of confusion. They stuck somewhere else, somewhere in between, right? They don't get the accurate answer. So what to do? So here I'm not going to apply the rule or procedure which I have learned, but I'm going to use my knowledge to how to represent a number and how I can break or regroup a number. That knowledge I'm going to use to solve this problem. First of all, I have to understand the visualization of this number, how I can visualize or represent this number. So 341 means I have 3 flat squares, right? 3 flat squares makes 300, and 40 means I have to drag 4 towers of tens, right? Okay, so this is my 1 tower, 2, 3, and 4. Altogether, I have 340, and I have 1 block only. Okay. So again, I'm doing addition. No, I was supposed to do subtraction. Let me just make it subtraction. Okay. Okay. So now I can see that I have 341 blocks to represent, where 3 flat squares of 100 unit blocks is there and 4 towers of 101 unit. Now I have to subtract 19, where I can see that there is 1 10 and 9 ones. So if I take consider the smallest value of this number, so I have to look that I have to subtract 9 units from this 1 unit, which is not possible. So what to do? So I have learned that I can represent this 341 into 300, then 30 tens and 10 ones, right? I have learned this. So I will just try to do that. I'll apply that, and I'll split this 10, tower of 10 into 9 small block, 10 in small blocks. See, all this I have split into 10. Now I can see, oh, now I have not just 1 unit, but I have 11 unit blocks. From here, I can easily subtract 9, right? So now I can just strike off or just remove, right? 1, 3, 4, 5, 6, 7, 8, and 9. Just a sec. Okay, so I think so 1 is here. Yes. So how many cubes are left in one's place? So I can see that there are 2 unit blocks. Okay. Now, again, if I move to the next place value, I have 110. So I have to cross out 110 tower from this 310 towers. See, so I can remove it or just strike it out. So now I can see clearly what exactly the number I am left with. 3 square flat square of 100, which makes 300, right? And 300, 2 tens make 20, and right? And I have only 2 unit blocks. So how easy it's for me to visualize and to understand that how like easily I can decompose this number as per the requirement. I'm not decomposing each and every unit. Wherever I need to decompose, regroup, and wherever I need to unitization. I need to use unitization process as well. So this is how I'm learning maths. I'm not doing maths. And doing maths again, if you have calculated, if you have followed a certain system, a certain procedure, and then you are verifying with the manipulative, that is called your doing maths with manipulative, right? So I have a few more examples to say and show you that how we can change this thinking. Like we can learn maths, we should not do maths with manipulative. Okay. Okay. Now let's do a multiplication sums, right? So before I do multiplication, and as we know that third onwards, we have 1 digit, 2 digit or multi-digit multiplications. Before we start that, I would like to do a few small 1 digit number multiplication so that you can understand that how these small multiplication questions are related to something factor and multiple, this kind of concepts, and how this is helpful to solve the questions with 3-digit numbers as well. So first of all, let me give you one question of 1-digit number. This is 2 multiplied by 3. So this here I can see that I have 2 groups of 3, right? So I need to represent, I'm using this small unit only. So I know 2 groups, 1 group and 2 group, and each group has 3 units, right? So let me group it. Okay. Yes. And each group has 3. So this is what I have made a rectangle, right? A rectangle, and where I can relate the horizontal line as a length and the vertical line as a breadth, right? So what exactly I'm doing? So here I can see that two group of 3 makes 6. If I just rearrange it like this, that I have 3 groups of 2, which is again makes 6. So here horizontally I'm making the grouping, and I'm doing the vertically, right? But this is nothing but called array. How different combination I'm using to represent the product 6, and which is nothing but the multiplicative a fact it is they are learning, right? So here they are able to understand, okay, this product 6 I can represent 2 into 3, 3 into 2, and another way is also there which I can represent using, that is just a sec. Okay, so I can make this wait, one horizontal line of 6 units as well, which give me the product 6, right? See, this is my one group of 6, or you can say that I can represent this product 6 into 6 groups of 1, right? So what all the group that I can make this number, like of this number 6. So I can get the product 6 by multiplying 1 times 6, or 6 times 1, or 2 times 3, or 3 times 2, right? And what all are these number represent about this product 6? These are nothing but the factors of 6. Similarly, when they develop this thinking, okay, if I have to multiply or get a product of two numbers, so what I'm doing, I am representing that number into different array, different combination, different groups. So what groups I can make to represent or to make the product 9? So I know that if I make one group of 9, it gives me 9, or 9 groups of 1, it gives me 9, or I can make 3 groups of 3 to make 9. So what all are these? These are factors, right? Again, okay. Now after these number, again I'm asking my child to find out in how many different groups you can find the product as 7. So again, they are using their understanding and the known knowledge from their memory, and they are trying to get that idea, like how many groups I can make to represent 7 as a product. So if I have one group of 7, so I can make 7, right? Or 7 groups of 1. Do I have any other combination, or can I make any other rectangle with another number? No, I cannot. Okay. Now let me ask about 5. How many rectangles you can create for 5? So I can make one rectangle of one group of 5, or 5 group of 1, but I cannot make more than one rectangle for this 5. So what exactly I am trying to make my children identify? So if they go through all these results and observe a pattern, what pattern they can make out of this? So they can say 6 has more than one rectangle, 9 has more than one rectangle, but this 5 and 7 have only one rectangle. So from here, they need our assistance to explain or make them introduce that these are called prime numbers. When you can make only one rectangle out of a number as a two factors or two groups, that is your prime number, and these are your composite numbers. So here they learned how to represent a product. They know that one of these elements should be placed horizontally and another part should be represented as vertically, arranged vertically, and whatever the area is being covered through this length and breadth, that is called the area, or you can say the product. So this knowledge they are going to use when they are going to handle 3-digit number or 4-digit number or 2-digit number while multiplication, right? Just let me cross this out. And if you have any question till here, so that you can just pose in the chat box. Meanwhile, I'm just arranging to represent a 2-digit number multiplication here. Let me check the chat box. Yeah, 2 rectangles of 5. It means I can make only one group of 5 or 5 group of 1. I cannot make any other rectangle, right? So 2 rectangles can be made, one horizontal and one vertical, but there should be no other combination. Only one combination will be there for 5, right? And same for your 7 also, right? Yes. Okay. So what if I want to explain this step, that how I'm learning and how I'm not doing math? So as a teacher, when I have already introduced the children, see, prime numbers are those which have only one factor, and composite numbers are those who have more than one factors. We have explained already in the class as a teacher in the classroom, and ask them, see, if I write a table of 5, so 5 ones are 5. 5 comes only in its table. But if I tell you 10, so 10 can become in can be found in table of 5, table of 2, table of 10. So this is composite number. This I have already explained. Now I bring my students to a maths lab class, or I bring some manipulative in the class and ask them, see, yesterday we learned about prime number and composite number. Just try to, whatever we have learned through the abstract number, just try to represent in using manipulative. That is what we are doing maths using manipulative. We are not learning. So if we give them the manipulative and then problem, and then ask them how they feel, how they think, how they visualize, and when they are coming up with the solution, and then we like summarize that this is called prime, this is your composite number, then the learning will retained by them. Then they will learn for whole life. They're not mugging up. They have owned their own learning. They have found out themselves. They have found the pattern in their own findings. That is what I'm trying to tell you, that every time that we should use manipulative to learn maths, right? Okay, now let's do a 2-digit number multiplication. So for that, I need to draw 2 lines, because I have to arrange in an array. One part should be arranged vertically and another one as a horizontally. Okay. Okay. Now, so I have a number 22 multiplied by 8. Okay. Let's start with a single digit number and 2-digit number, then move to the next level. Okay. So 22. Again, I know how to represent my 22. So 2 towers of tens I need for 20, and sorry, I have to arrange vertically these numbers, right? This rod, so that the place occupied by these blocks are visible to me clearly, right? I need to check, okay, and then 2 unit blocks. I will place just under this tens tower. Try to place it closely. Oh, this is disturbing me. Okay, so I will just arrange it here, because I'm handling this virtual manipulative, but if I am doing with physical one, it will be much more easier for me to place it as vertically or horizontally, right? So now on the top, I have 8 unit blocks, right? But I have placed 10. So I know if I remove 2 blocks from here, automatically I'll get 8. So I'll remove 2 from here. Now I can see there is a place which is which can be covered using all the bars, the rods, or this unit block to make a rectangle. Just let me identify this, right? So I can see this part, this whole part is the area which I need to cover with this manipulative, or you can say the tiles. Okay, so let me place it. Okay, if I place this, is it fitting over here? No, it's not fitting. I can see that one is extra over here. I cannot see it can be placed here. Okay, so now let me check. Can I do this also? No, I cannot. I can see that these 2 rods are 10 rods of tens are extra. So I need to split it out, and let me see if I can just remove it, right? Yes. Maybe you are thinking that this will take a lot of time, but taking time is not mean that you're wasting your time. You are giving them opportunity to understand, to feel that numbers. themselves. They are solving the problem by themselves. They are manipulating with the place available and the manipulative or the like tiles they have, right? So you are not telling them, do this, do that, remove this, remove that. From their own understanding, they are doing this, right? So they are learning. They are not just following some procedure or steps told by you or taught by you, right? Okay. So I can place over here. I can see still there is a place to accommodate few more tiles, right? So let me check. I can place it here. Yes, I can. Okay. It will take one more tower at the bottom. So, but again, I can see there are two extras over here. So I can just split it and remove it, right? So I can remove. Yes. Now I can count on all the numbers. So I can see here I have 8 times 10s and again 8 times 10s. So here it is 80, right? 80 and again here I have 80, right? And then at the bottom I can see 2 times 8, it means 16. Right? If I add all together 80, 80, 160, 160 and 16 all together, I have 176. So I can visualize my own work. I can visualize the quantification, the quantity that I have multiplied with, right? I know 22 into 8, but how it's going to look after multiplied with, right? So, and if I ask my children to represent through model, right? So I can ask them to visualize. And how did you think? How did you do that? You just represent through pictorial form. So how I'm expecting my children to do that, right? So they can represent this number operation using, see on the top, I can see 8 ones. There is no tens. So I will write 8 over here because the tens place is empty. And I have 20 vertically 20 and the bottom I have 2, right? So now I can see if I multiply this 20 with this 8 unit blocks, I can get 2 times 80, 80. Altogether, I get 160, right? I get 160. And if I multiply this 2 unit blocks with 8 unit blocks, I get 16 unit blocks. Right? And altogether, I get how much? I get 176, right? So this is how I can represent this, my area model, you can say, or the array model, okay? So this is what, where your product is unknown. But if you have a question where product is given and one part is given and the another part is unknown, so how I'm going to represent or use this manipulative to understand that problem and solve that problem, okay? So I'll just take another example. Just a sec. Okay. So again, I have this 2 lines, vertical and horizontal. Okay. Now I'll change the question. I'll have 13 multiplied by question mark. I don't know what is the number, but I know about the product, that is 169. Okay. I know the product 169, but I don't know what is the size of that group. This means there are 13 groups of objects. I don't know how many are there in each group? I don't know, but the total number of objects I know that is 169. So the child will make a connection between these numbers and they will understand, okay, 160 means the area that I'm going to build in within this place. And 13 is nothing but number of times that I need to get the object placed in. And on the top, I don't know how many numbers are there in each group or what is the size of groups, right? So I'm just erasing all these numbers. Okay. Yes. So I know 13. So I'll drag 13. This is my 13. Okay. Okay. This is my 13. Okay. Now I know 169. So I don't think so it will be possible for me to just place it and get the area with this unit cubes. I'll take the tiles. It will be easier to place in this area. Okay. So 100 and then I have 60. So I'll pull out 6 rods. 1, 2, 3, 4, and 5. Let me take the same kind of visuals here also, otherwise it will not match because I'm not taking the identical units, right? So it should be identical in nature. Then only I can prove my self that yes, my product is accurate or my selection of numbers are accurate. 13. So I need to have 13 here. So this is my 13. Now see how the difference I can then now make out. What was the problem if I use 2 different units, right? It's not possible to represent any number or solve any solution when you have different kind of unit. Okay. Yes. 3. Now I can see that this area should be covered till here only. I cannot make it, I cannot extend it beyond it. So I need to remove this 2. See, right? So I have put 100, 10, 20, 30. Now I need to accommodate 69. So more 3 towers. So I'll place here 1 and then 2, right? And more 1, 3. Oh, yes. Now I have full tens rod, but now I can see that I am missing out ones unit. How many ones do I need to place over here? So 9. So let me place this 3 under this 3. Yes. Group, copy, copy. Now see, I am able to fill this, make this area, this rectangle easily, right? Now I have to find out what numbers can be placed on the top of this place so that this area can be completed. So I'll just try to grab the blocks and try to get the idea what exactly would be the number. So I can see that if I place only 1 tower of 10, still I am the place is left with. So what unit blocks or what are the number of blocks I need to cover this space? So I'll just try to fill this out, or even your children can make out before placing all the unit. They will be able to tell you that, ma'am, here I need only 13, right? So here, so I can write 13 here. So this is what I'm learning using this manipulative. But if you have already taught them a procedure that 13 13s are always, it gives you 169, or you have taught them some trick, the trick that the double of anything, that 12 12s are 144, because we have a habit of learning all these things. Because see, when you are going to solve any middle term factors or anything else in the algebraic expressions, you have to have the square root of anything, the cube root of anything, be ready with. So we have mugged up all those numbers, the multiplicative facts, the 12 12s are, 13 13s are, 14 14s are, we have mugged up that those things. So what if you have learned that way and then you are verifying whether I have got the correct answer or not, that is what you are doing mathematics using manipulative, right? So before you do any calculation, before you do any use any procedure, you just go directly to use this manipulative, understand the connection between the number, understand how you can regroup and group to represent that number, then only you are going to learn or build flexibility among the students, the flexible thinking into their into them. Okay, so till here, any question? Yeah, that's Namrata ma'am, that's what we also learn, because this is the things that we need to use while solving algebraic expressions, doing identity. While applying identity, we have to be sure which number is the double of anything, cube of anything. So we have learned those things. But if I want my children to be flexible in their mathematics concept, then they have to apply themselves these manipulative to understand, to see, to visualize. Oh, really? If I have 13 times 13, it gives not a rectangle, but a square. They will give you this answer, right? And they will have this reasoning also. Do not stop just finishing this task. Just ask the questions. Why did you place 100 flat square over here? Why? So they can give you a reasoning that, ma'am, if I multiply or if I place 10 times 10, it gives me 100, right? Okay. Now 3 times 3 makes 9, right? 10 times 10 makes 60. 10 times 10 makes 100. And then 10 times 3 makes 30. And again, 3 times 10 makes 30. So this is what the visualization and understanding of the child, and do ask the reasoning, how did they do and what is the strategy that they have used. Maybe in your class, some child has used 10 and 3. Somebody would have used three unit blocks on the top and 10 star at the bottom. In that case, their structure will be different, right? That time, this will not look similar to this area, right? There you will have the opportunity to talk to the children about this number, and they have the opportunity to think and visualize, see, talk, and experiment with these numbers, right? So any other question related to use of Dean's block to understand any number operation, then I can do more. Otherwise, I'll move to fraction tile, which is again important tool to teach and understand the complex concept that is fraction. And that fraction is not at all a new concept. They have already learned in their previous classes in another form. And this is related with the whole number. And when they're going to learn decimal or percentage, they're going to use the knowledge and understanding from this fraction concept only. So any question? I'm waiting for 2 to 3 minutes, and after that I can just move to fraction tile manipulative. Diksha, any question?
No, ma'am.
No.
Yeah.
No, I don't think so. Any
I
question is
don't think
there?
so.
Okay. Yeah. Okay. Moving to use fraction tiles. Okay. Now, fraction is also one of the important topic to understand, because lots of students have misconception in fraction, right? And we understand that fraction is nothing but is just a number representing into two parts, right? But this is not the truth, right? So if I tell you, what do you understand by this term? Is it 3 upon 4? Three upon 4 objects? Is it what we want the students to learn? 3 upon out of 3 out of 4 objects we understand from this? What do you understand by this representation? Is it 3 out of 4 objects or 3/1/4? 3 out of 4? 3 parts out of 4? 3 out of 4? 3/1/4? 3, yes, 3/1/4. 4 out of 3, no. So when I'm representing any numbers into two parts in a fraction, it means there is no whole. There is a whole, but this number never represents a whole. It is of something or some part of that whole. This means this is nothing but 3 times 1/4. This is 3 times 1/4. Right? So let me more clear. Let me make myself more clear by using this fraction tile. Okay. So here we get confused. It is not 3 upon or 3 out of 4 objects, because this is already a part. I cannot say 4 object at all. That is already fourth part of an object, a whole object, the fourth equal part of that particular whole object. So this is my whole. Okay. Now, if I place this under my whole, clearly I can make my learners understand that this whole is divided into two equal parts, and each part is known as half. And this one part is nothing but 1 times 1/2. And this is again 1 time of 1/2. And if I combine two halves together, I get a whole. Okay. Now, same thing, I just pull out this fraction tile. What do I understand by observing this layer? So I can see that, okay, now this whole part is divided into 3 equal parts, and each part is 1/3. It is not 1 out of 3 objects. It is 1 part out of 1/3, right? So I have 3 equal parts, and this is only 1 part of 1/3. And this kind of 1/3, if combines together 3 times, then we get a whole. Okay. Now I'll pull another tile. So now, what do you understand by this? Again, same thing. I can say that this is nothing but 1 of 1/5 part, right? So 1 tile of 1/5, I can say, if I'm using this fraction tile, I can say this is 1 tile of 1/5, 1 tile of 1/5, and all 5 tiles of 1/5 together makes a whole. Now, from here, again, if I just drag 1/8 and just remove. Yes. Now, if I ask, what do you see? What do you observe? So I can see 1, 2, 3, 4, 5, 5 tiles of 1/8, right? So, but something is missing here, which is not which not makes this as a whole. So now I have to understand how many more tiles I need to make it a whole. So I have to place under this 1/8, the fraction, the unit fraction of 1/8 here, and I can see that 8 tiles of 1/8 make a whole. After getting 1, 2, 3, 4 examples, we can pose these questions to the children. What pattern do you observe over here? What pattern? In each case, what is the pattern that you observe? Now, anyone from the group would like to answer? What pattern do we observe till here? Half, 1/3, 1/5, 1/8. What pattern do we observe? Any pattern is there? the number of tiles are equal or are same as the number of fraction we have in each level. See, if we have two parts, so we need two tiles to make it a whole. If I have three parts, so I need to have three tiles to make it a whole. If I have 8 parts in a whole, so I need 8 tiles to make it as a whole, right? So this pattern, they can understand, okay, so number of tiles or number of fractions, I need to have the same as the number of parts I made that a whole, out of that whole, right? So that is, they understood, okay? Now let's move towards the next level and pull out few more fraction tiles over here. Now, next question, we can ask the child, do you find any fraction which has the same space occupied by half? This is the part that is covered by half. Now you have to identify which are the other fraction that falls under this space. So if I have this chart in my class and I ask my children to observe carefully, so they can find out by drawing this line like this, and they will say, yes, I can see similar fraction styles which occupy this space, and this is nothing but 1, 2, 3, 4, 4 tiles of 1 by 8. So 4 by 8 is nothing but same as half. And another is also can be observed that 2 tiles of 1/4, that is nothing but 2 by 4, which means 2 by 4 is also same as half. So what they can conclude from this observation, they can say 4 by 8 is equals to 2 by 4 is equals to half. And that moment, they need our help to introduce that equivalent fraction. So these are nothing but equivalent fraction to explain them, right? So what we are doing, first we are exploring the numbers or the number concept through manipulative, then we are coming to the terms to learn. We are not just learning the terms first and then verifying, right? So this is how we can teach them. We are not going to teach, they are going to learn themselves what exactly they are learning. These are equivalent fraction. They will never forget the term equivalent fraction if they learn by themselves. Yes. Okay. So now I can modify and ask the question like comparing the fractions, how we can use the fraction tile to compare. So a lot of time it's quite easier for the children to compare any fraction when they are like terms. It means they have the same denominator. So, but if we have different denominator, they get confused. And when then we as a teacher, what we do, we give them some trick to learn. Okay, denominator is zyada hai, so this is the way you have to arrange. If numerator is big, then you have to arrange like this. These are the tricks, these are the process that we want our children to learn, memorize, which is not good to build the flexibility. Okay, so I want my child to compare half with half with 2/7. Okay, which is more? So I asked which is more, half or 2/7. So let me check. Just place these tiles under each other and let me check. See, it's quite clear by this visualization that half is already exceeding, and 2 tiles of 1/7, 2 by 7 is just behind this half. So I can write it, compare it like this, right? Half is greater than 2/7. There should be no memorization that you need to compare the denominator first. If denominator is big and numerator is like that, so that is again falling under that memorization. So do not do that. You just ask them to follow this visualization and this manipulative to understand the concept, right? So this is how comparison can be done. Now I want my children to see how they can add and find the total. using this. So again, if the fractions are in like terms, it means if they have same denominator, it's quite easier for them to understand. But if they have different fraction like denominators, then we teach them first find out the LCM of the denominators, then multiply, then add. Again, those are the steps, those are the process that we want our children to memorize. That's what not is required, right? So I want my children to add 3/5 and 1/4, right? So I want my child to answer this, find this sum of this. So now I have to drag the tiles over here and check which is. So I cannot find any tiles over here which can fill this space, this whole space. See, I cannot find any. See. So if I have this, it means that this, yes, just a sec. See, this is also not covering the whole part. It means the fraction that I need, it is much lesser than the fractions I have, right? The fraction that I have 1/10, 1/12, 1/9, it means this space can be filled up by some other smaller fraction tile. So let me check with another and just take the different number, right? 1/5 and 1/2. Okay. So let me add half with 1/5. Now let me check which tile can cover up this the space that they have occupied here. So let me drag 1/7. Is it possible to get this place covered by 7? No, I can see the smallest part is overlapping, yeah, exceeding from here. So let me check another one. So if I place this, yes, this 1/10 tiles can cover this part. And how many tiles I have placed here? 1, 2, 3, 4, 5, 6, 7. So I can say that 1/5 plus half is nothing but, your answer is how many tiles? 1, 2, 3, 4, 5, 6, 7. 7/10. This is your total. In this way, they can arrange the tiles of fraction tiles and get the sum. Now, if I want them to use subtraction operation to find out the difference between two fractions, okay? So now I'm going to take the same number. I'll take half minus 1/5. I need to subtract 1/5 from half. So I would place 1/5 under this half. So whatever the leftover place is there, I need to find out a tile which can cover this space. So let me check with 1/4. Okay. No, I cannot find that this 1/4 will have the same space to cover this leftover part of half. No. So let me take 1/3. No, again, 1/3 is more than the space available over here. So let me check with some other. Okay. So shall I take with 5? Same thing, the children will also try to find. And as an elder, as a learned people, what we'll do, we will try to find out the LCM and then we'll grab the tiles, right? Okay, because the denominator is saying that I have the LCM of 2 and 5 as a 10, so I can grab this. And this is from our memorization, we can do it. But the children have not learned yet. They are trying, they are exploring the options, the the possibilities, and then they are learning through their own experiences. So to build flexibility, the experiences must be given to the children. They should own their own learning. They understand, okay, if I subtract 1/5 from 1/2, then I get 3 times of 10, 1/3, which is nothing but 3/10. So I get the answer like this: half minus 1/5 is equals to, I get 3/10. 3/10. Okay, 3/10. This is how I'm getting my differences. So this is the basic operation, addition, subtraction. Now we can find out multiplication and division as well. How we can do that? Just let me erase this. Till here, anyone, anything that you want to ask? Any question? Okay, now I'm going to do a multiplication question, that is half multiplied by 1/4. What does this statement means for me? How does it look like, or what visualization do I get
Zara
after
ma'am, sorry
reading
to
this
interrupt.
statement? Yeah,
So there's one question from Namrata Malhotra. So
yeah.
she's saying, how is it possible to solve for bigger numbers?
So bigger numbers, ma'am, we have to use tiles are not like essential for this bigger number. If you have 1/38 or 2/74 or 1/100, 2/100, that moment we have to take the Dean's block. The Dean's block that we have learned as a whole, then we have to represent that whole into fractions, right? Suppose if I just take you to those units, this. So big number I can represent using the Dean's blocks. If it is my whole, if I consider this square as a whole, so I have how many unit blocks? I have 100 unit blocks, right? So 1 unit block is nothing but 1/100 for me. If I break this 100 blocks into tens, so this one rod is nothing but 1/10 for me. And that moment we are going to use this Dean's block with the bigger number. But before we move to the bigger number, the children should have the clarity about the fraction and how they can solve, and what does these number statement means. They need to understand, then only they can deal and they can work on these big numbers efficiently. Right. So this half into 1/4 means it gives me an understanding that 1/4 has 2 halves. I have to represent 1/4 into 2 parts, and let me see what is the one part it's represented by this 1/4. Okay, so let me remove these tiles. So this expression means fraction. Yes, 1/4. Let me place my 1/4 under whole, right? Split it. And I have to know what is the half part of this 1/4. It means I have to divide this 1/4 into 2 equal parts. So what is the number that can be fit under into, or it can divide this 4 into 2 equal parts? So I can see that 2 tiles of 1/8 fills that space of 1/4. It means if I get a half of 1/4, I have 1/8. So here why my answer would be 1/8, right? This is my answer, 1/8. Okay. Now, next is my division. I need to understand the division part also. So division means if I write a question like this, 3/4 divided by half. Right? So this expression tells me that I have 3/4 part of a whole, which can be divided into two equal parts. Okay, so let me drag 3/4. This is my 4/4, which is whole. Let me make it 3/4. This is my 3/4. Now I have to have the half of it, right? So how I'm going to do that? Let me check out which. So can I see this? Is it possible to get? I need to add a half of it. No, it's not possible. It's not possible. So what I'm going to do? So let me check out another one, right? So here I can see that my 3/4, if I get a half of it, what I'm getting? 3/2. 3 times, right? So this is nothing but your extra. Is it that? Yeah. Half of 3/4. I have 3/4 and half of it can be, it's not possible to have half. Yes, I can do it. So 1, 2, 3, 4, 5, 6. I have 6 tiles over here of 1/8. And if I make a half of it, I can get 3 out of 8. Right? See, this is my number. Half of 1/3/4 is nothing but my this one. Yes, I got it. Right? So in this way, if my children are able to solve the problem using manipulative, so they are making their own connection with the number, right? Okay. So any other question? Yes. Three times half, yes. 3
You can
times
write down.
half is nothing but is your mixed fraction or your exceeding your whole, right? Yes. Okay. Any other question?
Please write down your question in the chat box.
Yes.
So, ma'am, Miss Namrata is asking, this type of teaching can be done in online mode only?
No, this is possible in your physical offline classes also. I'm asking you to use this kind of fraction tile, physical fraction tile in your classroom, right? And for your own understanding, for your own practice, you can use this site or you can ask the students to practice at home if they have the internet connections. So these are the free sites which we can use for practicing and explanation also. And if you have smart board in your classroom, you can use this also. This is quite visible to the whole class at a time, right? Yeah, I used it with a chart or cut out into pieces to make tiles. Yes, if I have the identical like chart paper cutouts, then only it will be possible for me to explain and make the children understand that how these fraction tiles are like interconnected or equivalent. If I'm able to make the cutouts identical, because if I have a hole, in that hole the rest of the fraction should be made, right? Yeah, it is 3/2. This is nothing but your more than whole. It's one extra than the whole, more than one whole, 3/2. See, if I divide a number 3/4 by half, I cannot divide a small number with a bigger number, right? Is it no? Don't you think so? Because 3/4 is smaller than half. So I cannot divide 3/4 by a half. Like we cannot divide 3 by number 4. Similarly, we cannot divide it like by half. So I have to find out like what is the half of 3/4 fraction is, right? But I cannot divide bigger number, smaller number from a bigger number. So if I do that, we get more than a half, fraction. Yes. Yes, I considered a chart a whole, then cut into 5 equals and so on to get identical tiles. Yes. So you divided a whole chart into 5 equal parts. That equal part is nothing but your 1/5, 1/5, 5 times 1/5. And then how you're going to relate that chart with other fraction tiles? How you're going to make them understand the connection between 1/10 and 1/5 if you have only 5 equal parts out of that chart. Yes, yes. Suppose after you have done this exercises, you may use this PHET site, which is again for a lot of interactive games and simulation for the concepts that you can provide. You can just encourage the students to use this site as well, PHET simulation, right? Here you will find a lot of teaching aids also, and simulation and games, level wise games also, and all the different subjects are also given, but I would prefer to go with the maths. If I click maths, there are lots of questions, but I need to check as per my level, grade level. So I just select elementary and then just check out. See, I have a lot of things to practice and play with, right? This is my fraction. So I can teach or I can learn the fraction using different shapes, whether it's 3D or 2D. I can introduction. This is game, and then lab activities are also there, and these are not meant to be done by this teacher. These are the games that students will play as per the level that they gain after completion of each level, right? So maximum, okay, 3. Right? So I can use, this is 1/1 whole. This is whole. Okay. If I increase like this, see how I'm getting the visual for each and every things, right? So this is my introduction. If I want to see how this is going to change and represent my fractions, so it will change. So I have taken 2 whole, where one whole is shaded with one part of it shaded, and these 2 whole circles are divided into 5 equal parts. If I just increase the numerator, so this will fill up the colors part, and now I get a whole. But if I increase the numerator, instantly I can see the 2 holes and the part of them colored, right? So this is how it is, the introduction in shape, circle shape. Now I want to see in tape or the rectangular shape. Now see, right? And here it will change this tags as per the fraction I'm selecting over here, right? This is vertically, this is your cylindrical, right? See, I have taken 3 maximum holes and how they are representing my fraction, right? Okay, now the most classic example that we give while teaching your fraction is your cakes and pastries, sandwiches, and pizzas, right? Once now I can represent my fraction using number line as well. So where exactly this 10 by 4 lies? So I can see that 10 by 4 is here, somewhere here. I have three holes, 0, 1, 2, 3, and each hole has been divided into 4 equal parts. This is 1/4, 2/4, 3/4, and this is 4 by 4. This is 5 by 4, 6 by 4, 7 by 4, and this is 8 by 4. And now here 9 by 4, and this is 10 by 4. So here the child is understanding about the fraction, how to represent, how to explain, how to identify, and then they can play the games as well. Now, again, I'm just going to that window only because I have done only introduction. Now I want to play the game. Level 1. So, half. These tags are kept here as per the fraction at the right side. I need to drag them here from here. So I know, no, this will not take. This will not take. Okay, let me check. Yes, it's 2 by 2. Let me place here. Yes, it's correct. Now, the next one I would like to show. This is 1/3. Okay. Yes. Now I need to find out where is the half. Okay. Now see, I don't have anything which represent half. See, I don't have. See, I have a whole, but I have already used the card present here as a 2 halves, which makes a whole, but I have already used, right? I don't have to fill this half blank space. So I will just get it back and place it correctly and then pull out another card from here to make it a half and present here. So one level done. Now next level, again I have to see, okay, there is 2 by 4. Now I have to identify and just try to understand which has the correct number of equal parts. So I can see 1, 2, 3, 4, 5. Okay, I can make the drawing or the representation for this 3 by 5. So 5 parts. Yes, no, it's 4 parts. 5. Yes, now I got it. So how many parts should be covered, or like, yes, it is the correct answer for this option. So I placed here. Now 2 by 4. Yes. So like this, I can play with this 2 by 4 again. Yes. Yeah. Done. So in this way, the child can play this also. The simulation is also there. We can directly contact us. Yes. And we provide it only in digital. Yep.
Ma'am?
Diksha, can we
Yes.
share this link, this PHET
Yes,
link?
sure. I'll
Yeah.
share the link with everyone in the chat box.
Mhm.
And I think it's time for us to start our quiz round.
Yeah. Thank you, teachers, for sparing your evening with me. Thank you. Hope
Thank you so much,
these
ma'am.
the usage of manipulatives, you have the knowledge, like you got the idea how to implement in your classroom. It's just not the first you have to introduce the concept, you have to teach them the procedure and then use this. No, first of all, just let them explore with the manipulative, give them the connection, give them the experience, and give them the like opportunity to think themselves, and then help them, right? Yeah.
Thank you
Thank you,
so much,
Diksha.
Ira, ma'am.
Thank
Thank you
you.
so much. It was a
Thank you.
wonderful session.